Good afternoon. Good afternoon, one and all. So today, we'll go through the analysis of indeterminate structures. On that, we talked about the Carney's method. So model 3. So in the yesterday problem, so we are facing the end A and end D. Both the end supports are fixed. Now we talk about the end supports are hinge supports in this problem. So introduction, already you have studied in the previous session. So Carney's method is the best suited for analyzing the indeterminate structures like that. So Dr. Gaspar Carney developed the method, Carney's method. So already we have studied this and steps involved. The step 1, fixed end moments, we have to determine the fixed end moments and determine the rotation factor. So based on the relative stiffness, we have to calculate the rotation factor. Determining the relative stiffness based on the support condition. The K by summation of K is distribution factor. The minus half into distribution factor is our rotation factor. So here in the figure 1, so we are concentrating the K values. So for the different support conditions, if it is fixed, K is equal to I by L. It's a pin, K is equal to 3 by 4 I by L. So AD, so simple support, K is equal to 3 by 4 I by L. So AE, it is a continuous. If it is a continuous, K is equal to I by L. KAG, it is 3 by 4 I by L because of hinged. If roller, 3 by 4 I by L. So like that. So we can talk about the spans AH, AG, AE. So now comes to the AEF. So KEF, the position of F, is it fixed? No. Continuous? No. It is a hinge simple support. So it is 3 by 4 I by L. It is not a continuous. So already we have discussed earlier. So step 3, we have to calculate, or we have to assume that M dash contribution values, M dash AB or M dash DA, the end supports. And the step 4, extreme simply supported ends will initially get a fixed end moment. So already we have studied that. That figure 2, so this is the flow diagram, what we have to write MFAB, MFBA like that, and rotation factor. So inside the box, and in the smaller box we have to check summation of two fixed end moments with the related joint. So like B, MFBA plus MFBC, so you have to write in the smaller box. So in the fifth step, so we'll go with the iterations. Already we have studied in this first session. So next, final moments. So today we are talking about a continuous beam where the end supports are the hinge support. So here it's very important. Already the moment will be known. The moment at AB is equal to 0 and DC will be equal to 0. So we have to calculate the joint B and joint C, MBA, MBC, MCB and MCD. So next we have to calculate the fixed end moments. So we have to calculate for all the spans, MFAB, MFBA, MFBC, MFCB, MFCD and MFDC. So here we have to calculate all the values, MFAB. So depending upon the loading condition or type of the load, so we have to calculate the fixed end moments. These are the values. So in the next step 2, so it is very important, where all the values are not I by L. So BA is equal to 3 by 4 I by L, BC is equal to I by L, CB is equal to I by L, and CD is equal to 3 by 4 I by L. So BA, so here B to A, so check what is the position of A. Is it fixed? No. Is it continuous? No. So it is a roller support. So K is equal to I by L. So you have to check with the sequence, is it fixed, continuous, hinge, roller, simple support. If it is a fixed support, it will be I by L. If it is continuous, I by L. Rather than that, in all the cases, it should be 3 by 4 I by L. So here, so it should be 3 by 4 I by L. Now BC, come to the BC, see here, B to C, what is the position of C? What is the position of C? Is it fixed? No. Is it continuous? Yes, it is a continuous. So the K is equal to I by L. So it is a different method to determine the K values. Actually there will be other procedure also, the technical procedure. So we can go with this, otherwise you can go with this, undergraduate students. So you can go with the next. So CB. So come to the CB here, C to B. Check what is the position of B. Is it that support is fixed? No. Continuous? Yes, it is a continuous because one more support, A support will be there. So CB is a continuous one. So K is equal to I by L. Next come to CD. C to D. So here C to D. What is the position of D? Is it fixed? No. Is it continuous? No. It is a roller support. So K is equal to 3 by 4 I by L. Keep in mind, if it is not fixed and not continuous, it should be 3 by 4 I by L. So you have to calculate the K value, summation of K, distribution factor. Otherwise you can directly take rotational factor minus half of K by summation of K. So there is no required of this. There is no required of calculating the distribution factor. So you can directly go to the rotation factor. Directly go to the rotation factor because minus of half into K by summation of K. K by summation of K is the rotation factor. The next, rotational contributions. So here iterations are developed. Before that, an important thing, the support A and support D are hinge supports. Support A and support D are hinge support. Here the moment is equal to 0. Already known moment. If there will be a known moment, so we will go with the internal balance. We will go with the internal balance. Go with the internal balance. Whatever may be the fixed end moments. So subtracting and adding. Take the internal balance of the value, subtracting or adding. So we will get 0 value. Initially you have to calculate because the moment will be known. Already you have known that. Already the value is known, that will be 0. So go with the internal balance. When you will go to the internal balance, so there will be a carryover. Then only the iteration will be completed. Already you have studied in moment distribution method. So this procedure is in moment distribution. Already you have studied internal balance. If you have a balance, the 50% of the balance to the far end support. So that will be carryover 64.8 plus 64.8. The 50% is 32.4 plus fixed end moments. So you will get the final fixed end moments 0, 75.6. Here there is no any internal balance and there is no carryover. 57.6 is the final fixed end moment. 38.4 is the final fixed end moment. And here it will be very important again. So the moment is 0. Already you know that because it will be a hinge support. So what you will do? So adding or subtracting, make the balance. Adding or subtracting the same value of fixed end moment. So that will be 40. Take the balance of minus 40, make it 0. If you will consider the internal balance as a minus 40, there will be a carryover of 50% of that moment. So minus 40, 50% is minus 20. So minus 40 and minus 20, it will be minus 60. This will be the final fixed end moment. So 0, 75.6, 57.60, 38.4, minus 60, and it will be 0. See, if you are skipped in this situation, so everything will be wrong. So go to the internal balance. After the balance, there will be a carryover, 50% of that. And here also, make the balance plus 40, make it the internal balance, adding or subtracting. some value, so final value will be 0. If it is plus 30, make it minus 30 and make it 0. Then carry over is minus 50, like that. So that will be example. So how to consider the 50% and as well as the internal balance. So based on the balance, so you have to calculate the MFB and MFC. MFB and MFC. 75.60 minus 57.60. So you will get MFB. Plus 38.4 minus 60, you will get minus 21.60. These will be the MFB and MFC values. MFB and MFC. Summation of MFBA plus MFBC, that will be 18. Summation of MFCB and MFCD, that will be plus 18. So in the next, so the same procedure, the iterations are there. So you can calculate it directly. You can calculate here because in the first step, 18 plus far end will be 0. There is no any values. 18 plus 0 multiplied by 0.215. You will put it here. Divided by this, multiplied by this, you will get 5.13. Next, come to the 21.60 plus 5.13 multiplied by rotation factor, you will get 6.95. Divided by this 0.26 multiplied by 0.24, you will get 6.41. These are the iterations because the equation will be the same. Rotation factor into the MFB plus far end moment 0.215. 18 is the MFB value. So initially the far end is 0. So you will get 3.87. Then M dash BC, rotation factor of BC, MFB plus far end moment. Initially it will be 0. So you will get 5.13. This 5.13 is the far end moment. This 5.13 is far end moment of joint C. M dash BC is the far end value of joint C. Joint C means it comes to the CB as well as CB. Only one far end moment will be there. That will be minus 5.13. See here. So already we have calculated. So 5.13 and 5.13. So minus 0.26 is the rotation factor of CB. 21.6 is the MFC value. The far end is M dash BC, that is 5.13. So you get 6.95. The same procedure you will adopt here. The far end is minus 5.13. You will get 6.41. So come to the second iteration. Again, it will be the same. Minus 6.95. So what the last value? So this one, yeah, it's not minus 6 point, so it will be plus 6.5 value. So it will be plus 6.5, it's not a minus. So it is plus 6.95. Sorry for that. So 6.95 because earlier, see here, this value M dash CB. M dash CB is the far end value of joint B. So 6.95 and 6.95. So here 7.11 is the far end value for the second iteration in the calculating M dash CB. M dash CB at the same procedure. Then third iteration and fourth iteration, nearly the third and fourth iteration are same. Nearly it will be same. So we will consider 5.48, 7.26, 7.5 and 6.92 are the final contribution moments for M dash BA, BC, CB and CD. So here, in the next we have to calculate the final net moments. So already we have internal balance or in support the moment at AB equal to 0. Then BA, so we have to calculate. So it will be 64.64, 64.64. And one more thing, if you have a M dash B, MBA and MBC, it will not same. The plus or minus 0.4 or 0.5, it doesn't matter. because in the decimals we are not getting the same values. Sometimes 64.6 and one more value 64.4 like that, or 3 like that. Doesn't matter if there will be 0.5. Then next MCB, MCD and MDC. Again MDC is at 0 because of internal balance. Otherwise there will be in support. We know that it will be 0. It will be bending moment diagram. So sorry. So 64.64. Okay, fine. Okay, a small changes here. So 64.7, yeah, okay, it doesn't matter. And 46, this is the bending moment diagram. The next shear force calculation. So we have values RA, RB, RC and RD. So 48.06. Sorry, 41.06, 48.94, 51.74, 71.5 and 48.5. So these are the shear force values. Just you have a point load, take 41.06, then down, then the total load minus of 41.06, you will get 48.94. The RB minus of 48.94, you will get the 51.74. If it is a point load, take the straight line, 51.74 minus total load, so you will get this height. Then take the straight line because of point load, then that will be total load minus of 51.74, you will get 28.26. So RC minus of 28.26, you will get 71.5. If it is a UDL, take the triangle shape, the total load of UDL minus of 71.5, you will get 48.5. Thank you one and all. So MCQs, multiple choice questions are already uploaded, so you can go through that, so you can solve this. So all the values, all the questions you have to solve. 30 questions are there. So choice questions already you have. The ABCD options are 1, 2, 3, 4 options. So correct the choose one. Study well. Thank you.